Lesson 2.7. From this video, you should learn how to graph absolute value functions. Okay, the graph of an absolute value function is in the shape of a V. I'm going to go ahead and draw the parent graph to show you. The vertex of the parent graph of an absolute value, since it's absolute value of, or it's y equals absolute value of x, it's going to be 0, 0, 1, 1, 2, 2, 3, 3, and so on that way. But the absolute value of negative 1 is positive 1. So it's going to be negative 1, positive 1, negative 2, positive 2, negative 3, positive 3. And it's going to be in the shape of a V. That's what the parent graph looks like. For A, we're going to graph it using a table. So we're going to choose negative 2, negative 1, 0, 1, and 2. When you plug in negative 2, you get 2. 2 minus 4 is negative 2. When you plug in negative 1, you get 1. 1 minus 4 is negative 3. 0 minus 4 is negative 4. 1 minus 4 is negative 3. 2 minus 4 is negative 2. So when you graph that, you get negative 2, negative 2, negative 1, negative 3, 0, negative 4, 1, negative 3, 2, negative 2. And I still have a V, but this one doesn't go through the vertex of this one's not at the origin, it's 4 down. The reason it's 4 down is because of that vertical translation right there. That means down 4 units. So you're going to take each point on your parent graph and you're going to shift it down 4 units. We're going to graph B using translations. So this plus 2 right here means it's going to go up 2 units. So our parent graph has a point on the origin. We're going to put our graph a point 2 up from that. Our parent graph has a point at 1, 1. We're going to go 2 up from that. There. And then the next one's going to be there, and then there. On the other side, negative 1, 1, we're going to go 2 up. So it's negative 1, 3. And then negative 2, 2, we're going to go 2 up from that, and it's negative 2, 4. And that's what you would get. Even if you made a table, you'd get the same thing. But in this case, we don't have to because we graphed it using translations. Okay, now we're going to combine translations. For this graph, we go up 3, but we also go left 2. So I'm going to graph the parent graph first. By now, we should all know that it's 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, negative 1, 1, negative 2, 2, negative 3, 3, negative 4, 4. So there's my parent graph in black. Now each point for my parent graph, I'm going to move up 3 and left 2. So instead of 0, 0, I'm going to go up 3 and left 2, and I'm going to put my new point there. Instead of 1, 1, I'm going to go up 3, left 2, new point here. Instead of 2, 2, I'm going to go up 3, left 2. 4, 4, up 3, left 2. And I have one side. Instead of negative 1, I'm going to go up 3, left 2, new point there. Instead of negative 2, I'm going to go up 3, left 2, new point there. Now you have your graph. You didn't have to make a table. You can make a table, but you're going to get the exact same points as if you just use the translations or the transformations. Okay, let's combine them again. This one is going to take you up 1, and then the minus 2 is going to go right 2. So instead of at the origin, we're going to go up 1 and right 2. Instead of being at 1, 1, we're going to go up 1 and right 2. Instead of being at 2, 2, we're going to go up 1 and right 2. I got that side. And then the other side, instead of at negative 1, 1, we're going to go up 1, right 2. And then instead of being at negative 2, 2, we're going to go up 1, right 2. You have your graph. Alright, vertical stretch and compression. This is where you take your graph and you're either going to half the y values, or you're going to, not half, but you're going to divide the y values and you're going to compress it, or you're going to multiply the y values and you're going to stretch it. if the number in front of the absolute value is between zero and 1, then that's a compression. So I could do this by making a table, and I think that's how I'm going to do it first, so you can see it. I have to half these numbers, so I'm going to choose like -4, -2, 0, 2, and 4, because those are easy to take a half of. So the absolute value of -4 is 4, half of that is 2. The absolute value of -2 is 2, and half of that is 1. Half of 0 is 0, half of 2 is 1, half of 4 is 2. So I made my table. Let's graph those points. -4, 2, -2, 1, 0, 0, 2, 1, 4, 2. Now, if you inspect this and you compare it to the parent graph we've had before, and I'll go ahead and put that parent graph on here so you can see, it would look like this. And when you compare, you notice that our pink graph, the graph of our function we have here, is wider than our parent graph. The reason being is because of the 1/2 multiplied out front compresses our graph. Each y value has been halved. So instead of being at 1, now it's at 1/2. Instead of being at 2, now it's at 1. Instead of being at 3, it's at 1.5. Instead of being at 4, it's at 2. Okay, so now I have a 2 out front. What I'm going to do now is translate the parent graph. So I'm going to draw it really quickly. And then I'm going to double every single y value. So instead of 1, I'm going to double 1 and I'm going to put the point at 2. Instead of being at 2, I'm going to double it, I'm going to put it at 4. Instead of being at 3, I'm going to double it and I'm going to put it at 6. Instead of being at -1, it's going to be at 2. At 1, it's going to be at 2. 2 is going to be 4. 3 is going to be 6. Now if you graph the sides of your absolute value, you notice that my graph of my function is skinnier than the parent graph, and the reason being is because I multiplied every y value by 2. I stretched it. Okay, the general form of an absolute value function is most of the time going to look like this, where a, h, and k are numbers. If a, the number that's in there for a, is greater than 1, that is a stretch, so you're going to multiply. If a is between 0 and 1, that is a compression, so you're going to divide. Your vertex for an absolute value is located at the point h, k. Because your h in your general form is negative here, that means you're going to do the opposite for h of what's in your equation. The k is going to stay the same, but it's going to be the opposite of what's in your equation. Then your axis of symmetry is going to be the line x equals h. Remember again, h is the opposite of what it is in the function. Now without graphing, what are the vertex and axis of symmetry of the graph? So this is a, this is h, this is k. The vertex is going to be the point hk, where h is opposite, so my vertex is going to be positive 2, 4. My axis of symmetry is going to be x equals 2. Again, I'm not going to fill all this out again. You can look at what you already have. But another function here, they want to know the vertex and the axis of symmetry. The vertex is going to be the point hk. which here is going to be positive 1, negative 3. And your axis of symmetry is going to be x equals h, which is 1. Now we're going to write the absolute value function. All we need is a vertex to do this because it's hk, and we need a stretch or compression factor, so we need an A. Okay, so first thing we can find is the vertex because that's really easy, so that's going to be negative 1, 4. So I'm going to erase this and put negative 1, 4. Then we need to find our stretch or compression factor. To find the stretch or compression factor, all you really need to do is find the slope of the right leg of the graph. The slope of this leg is going to be a little bit difficult to find, but I'm going to give you a second point on there to help you out a little bit. And then all you have to do is do rise over run, so it's negative 1 over 3. So your A is negative 1/3. So your equation in vertex form is going to be y equals negative 1/3 x plus 1 plus 4. Okay, so we're doing the same thing again. The vertex point is the first point we find, and that's going to be 2, negative 1. And if we find the slope of the right leg, it looks to me like we have a point here and then another point here. So that's going to be 4 over 1. If you do slope, rise over 1, you go up 1 over 4. So it's 1/4, I'm sorry. And so your A is going to be 1/4. So your equation is y equals 1/4 x minus 2 minus 1. And that's y equals A, x minus h plus k. Okay, so I want you to do these 3 questions on your own. Show all of the work that you possibly can on a separate sheet of paper and bring it to me tomorrow for proof that you did your homework.